Hello, my name is Darren. I'm here to talk about and to draw an oblique isometric diagram from these three drawings, the front, the top, and the side. First of all, an oblique surface simply is a surface that doesn't have parallel lines to anything else. It's just odd shaped, doesn't match up 90 degrees to any other side or angle or surface. The reason why a lot of times these things are used is simply to fit one thing into another, and not everything is quite so 90 degrees parallel or match up perfectly, so some things have to be designed or shaped or contoured to meet another surface, and that's why designers use oblique surfaces. Okay, so we are going to draw one here. First thing you want to do whenever you have a multi-panel and you want to turn it into an ISO is to identify your normal surfaces. Now your normal surfaces are going to be the ones that are a surface in only one of the drawings, but are a line, horizontal, vertical in the other two. And make sure that it's not an inclined surface, because an inclined surface is a foreshortened surface in one and a line in the other. And of course an oblique is none of the above. It is simply a odd shaped surface in all three diagrams. It does not correspond to any specific line, and that's how you can point it out. So we'll start with the front view to figure out which one is our surface, or our normal surface. Let's start with this triangle right here. We can see that here is the surface, and if you look up here, I believe it's going to correspond here. These 2 points obviously match up, and it's also going to be this surface is going to be just this one actually. So we know that that's a line, and it's also going to be this one right here, and that's another line. So that is the surface we would call A. This one doesn't really match up to anything else. It's odd looking, which meets the specifications of an oblique surface. So I'm pretty sure this is our oblique surface, but we'll continue with the normal ones for now. We'll start with this other triangle. You can tell like these 2 points correspond, so it's, and then this line here corresponds with this line. So this line is this surface, and it's also this line here on this one. So yes, this is another surface, normal surface that we found. So we'll call this one B. Same with this one, same as this one. It's odd, it doesn't really tell. Obviously this is the same oblique surface as in the front view. So we want to the side and start with the other triangle. This corresponds directly with this. These 2 points meet up. So this line is this surface, and is also the depth here, this is this line, this is another surface, we'll call it C. And since this one also doesn't meet up with anything else and everything else is defined, this must be our oblique surface, we'll call it D in all three, because it is just one big surface. Alright, to start the ISO, we'll just pick one to start with. Go with A. It is 6 across the bottom. So we'll start here. 1, 2, 3, 4, 5, 6. 4 up to the left. So 1, 2, 3, 4. And then it comes down to a point 1 up from this one. So right here. And draw this. Finish it off, and that is our surface A. Going with B, it is 1, 2, 3, 4, 5, 6 back. 1, 2, 3, 4, 5, 6, and it goes 4 across the back. 1, 2, 3, 4, and then this line connects with this point. So draw it all the way across. And then we'll move on to C. It is 3 up, 6 back, so 1, 2, 3, 4, 5, 6. And then 3 up. Actually, 1, 2, 3, 4, 5, 6. Yeah. Gotta make sure, measure twice, cut once, right? Up 3. And then this point connects with this point, same point here. And that's kind of crooked, but it works. And then this is our C. And then we have this big gap right here. So this is obviously our oblong surface. So we need to connect here. You can see this point connects with this point, which is, you know, this one with this one. So it's this one with this one. I forgot to label this one. This is obviously our B. And then this is our D, since we filled it out. And this is your oblong surface, and this is the isometric drawing of it. Thank you for watching.